Welcome back, everybody. We're going to finish Chapter 6 now, Section 6.6. And we're going to close the door on Chapter 6 by solving what are called higher degree polynomial equations. And we're going to solve these equations by using our factoring skills. And that's why this section comes last at the end of Chapter 6, because we had to, first of all, learn how to factor polynomials in Chapter 6 to have any chance at being successful in solving these higher degree polynomial equations. In general, the first step you want to utilize when solving these higher degree polynomial equations is you want to first of all get the equation set equal to 0. If the equation is not set equal to 0, you're going to have to do some algebra on it to get it set equal to 0. So that's the first requirement, is our equation must always be zeroed out or set equal to 0. Once we set our equation equal to 0, we need to completely factor the left side of our equation. And once we completely factor the left side of our equation, then we're going to set each variable factor equal to 0. And what justifies us in doing such a thing is this theorem. There's a theorem in mathematics. A theorem is a proven valid statement in mathematics. This theorem says this: if A times B is equal to 0, then either A is equal to 0 and or B is equal to 0. This is a very easy to understand theorem, unlike most of them. This one makes sense. Whenever you multiply two things together and you get a product of 0, this theorem goes on to guarantee that at least one of your factors has to be 0. That kind of makes sense. Once we set our variable factors equal to 0 in using this theorem, then what we do is we solve the resultant simpler equations. So this in general provides a guideline or a roadmap, if you will, as to how we go about solving higher degree polynomial equations. All right, let's begin. So the instructions in this section are not going to say factor anymore. The instructions are going to say solve, because we're going to turn our attention back to solving equations. We'll look at this one first. Ladies and gentlemen, what we have here is we have a second degree equation. It's called a second degree equation because the highest degree term on the left side of this equation is of degree 2. Now, when we solve this second degree equation, we ultimately are going to get two solutions to this equation, not just one solution like we did in the past when solving first degree equations. In fact, there's a theorem in algebra called the fundamental theorem of algebra that guarantees that when you solve an nth degree polynomial equation, you're going to get n solutions. Since this is a second degree equation, we will get two solutions. Now, step number 1 of those guidelines I just listed on the previous page says, first of all, we need to make sure our equation is set equal to 0. Well, we're lucky, because as this equation is presented to us, it's already zeroed out. It's already set equal to 0. Now, the second step says we now need to try to factor completely the left side of this equation. So we're back to our factoring skills. So as we look at this left side, we ask ourselves, can it be factored? Well, there's nothing we can factor out of all three terms of this polynomial, and therefore we have to realize that we have a trinomial. Upon further inspection, we realize that we have an easy type of trinomial, one with a leading coefficient of 1. To factor this trinomial completely, all we need are two factors of the constant term -6 that sum up to the middle coefficient of -1. So feel free, if you want to, off to the side of your paper, make the product sum table here, realizing we need a product of -6. And those factors of -6 must sum up to -1, the middle coefficient. Let's start listing factors of -6. -1 and 6, 1 and -6, -2 and 3, or 2 and -3. These are all the factors of -6. Now, the only factors in this list that sum up to -1 are going to be the last ones, namely 2 plus a -3. Those are the only factors in this list that add up to -1. So 2 and -3 are the only factors that are going to enable us to completely factor this trinomial on the left side of our equation. To factor it now, we rewrite it as the product of two binomials. Hence, this trinomial factors into x plus 2 times x minus 3. Or you could have these switched around. You could have x minus 3 times x plus 2. Now that our left side of our equation is completely factored, the next to the last step is we take each of these variable factors and set them both equal to 0. We are justified in doing that by that theorem that I cited on the previous page. So therefore, x plus 2 is equal to 0, and we set x minus 3 equal to 0. And all that remains now, ladies and gentlemen, is solving these simple first-degree equations for their individual solutions. To solve this first-degree equation, we just subtract 2 from both sides of the equation, and we get x equals -2. Now solving this equally simple first-degree equation, we add 3 to both sides, and we get x equals 3. And we're done. Our two solutions to the second-degree polynomial equation back up here are -2 and +3. We're done. Let's try another one. Here we have another second-degree equation to solve, and so when we get done, we should expect to have two solutions, just like we did with the previous second-degree equation up here. Notice our equation is initially set equal to 0. We're good there. The next step now is to ask ourselves, can we factor this left side of our equation? Notice upon inspection, we should realize that we can factor 100 out of each of these three terms on the left side, so we do that. Let's pull the 100 out. Times what would we leave behind in doing so? Well, when you factor 100 out of 100x squared, you'll leave behind just x squared. Minus, when you factor 100 out of 300x, you leave behind 3x. Plus, and when you factor 100 out of 200, you just leave behind 2. Now, ladies and gentlemen, we got to ask ourselves whether this trinomial left behind inside the parentheses itself can be further factored down. Notice, fortunately, we leave behind an easy type of trinomial, one with a leading coefficient of 1. To factor this type, we need two factors of +2 that sum up to the middle coefficient of -3. The only factors of 2 that work are going to be -1 and -2. Because -1 and -2 are the only factors that sum up to -3. Notice I did not make my product sum table over here to the right side on my paper. You could have done that, but I took a little shortcut this time, and hopefully all of you will get good at this, factoring these types of trinomials, where you don't have to do this product sum table anymore. Basically, all you have to do is just come over to the constant term and ask yourself what are factors of it that sum up to the middle coefficient. Once you find them, boom, you can immediately factor this trinomial now into the product of two binomials, namely x minus 1 times x minus 2. Now the left side of this equation is completely factored. Being the case, we now set both variable factors equal to 0. Now some students are saying, is 100 one of your solutions to this equation? The answer is absolutely not, ladies and gentlemen. You don't set 100 equal to 0 because to say 100 is equal to 0 is an absurd statement. The only way this left side of this equation could be equal to 0 is if one and or both of these variable factors are 0. So for that reason, you only set the variable factors equal to 0. Don't ever set a constant equal to 0. It doesn't make sense to say so. Now when we solve this first equation for x by adding 1 to both sides, we get one solution to our second degree equation, which is +1. And solving the second first degree equation by adding 2 to both sides, we get our other solution to this equation, which is x is equal to positive 2. And ladies and gentlemen, we're done. We have found the 2 solutions to this second degree equation back up here. So this is called the factoring method for solving higher degree polynomial equations. With practice, you will get good, but it just requires that you spend time with this material. Remember, hard work equals good things and success. In the backdrop, I hear the Grand Ole Opry. The Grand Ole Opry is still going despite this craziness with this virus. My son's watching the Grand Ole Opry, so it's good to, hear at least something's normal. All right, let's try another one here. I didn't want that one here. Okay, we're going to take x squared equals 10x minus 25. So we're going to try to solve the second degree equation. Whoops, we're going to solve the second degree equation for its 2 solutions. And again, it will have 2 solutions because it is a second degree equation. Well, ladies and gentlemen, this one's a little different than the previous 2 because we first of all realize that this equation is not set equal to 0. So the very first move we have to make on this equation, or the first step we have to do, is we must get this equation set equal to 0, or we must zero this equation out. To do that, we're going to have to drag a positive 10x over to the left side of our equation, and we're going to have to drag a negative 25 to the left side of our equation. How do we do that? Well, to move a positive term to the other side of the equation, we subtract it from both sides. So we're going to subtract 10x from the left side of our equation, and we're going to subtract 10x from the right side of our equation. And to move a minus 25 to the left side of our equation, we're going to have to add 25 to both sides of our equation. So we're also going to add 25 to the left side of our equation, and we're going to add 25 to the right side of our equation. Notice after doing this, the 10x's drop out on the right side of the equation, so does the 25. And so we're left with this trinomial on the left side of our equation, x squared minus 10x plus 25. And now our equation has been zeroed out. It's set equal to 0. Now that our equation is set equal to 0, we just have to try to completely factor this left side of our equation if possible. Notice there's nothing you can factor out of all 3 terms of this trinomial. And so we're going to try to factor it as an easy type of trinomial, one with a leading coefficient of 1. To do so, ladies and gentlemen, all we need are 2 factors of the constant term, positive 25, that sum up to negative 10, the middle coefficient. Well, the only factors of positive 25 that could potentially work would be just the negative factors of 25, negative 1 and negative 25, or negative 5 and negative 5. The only factors of positive 25 in this list that sum up to negative 10 would be the negative 5 and negative 5. Those are the only ones that add up to our negative 10 or middle coefficient. Being the case, this trinomial immediately now factors into 2 binomial factors, namely x minus 5 times x minus 5. And now we set both these factors equal to 0 since they're variable factors. And then we just solve both resultant first degree equations. Notice they are identical equations, so they're going to generate identical solutions, namely 5. So as it turns out, this equation, the second degree equation, does have 2 solutions, but it just so happens that the solutions are repeated solutions. And ladies and gentlemen, you don't have to list these 5s twice. We say that 5 is a solution to the second degree equation with multiplicity of 2. In other words, it repeats 2 times as a solution. And we're done. That one's been solved. Okay, we'll try to solve this one here. Notice this equation is all messed up. For one thing, we're used to having 0 on the right side of our equation, and that's an easy fix though. Let's just flip the whole equation around. No harm done, still the same equation. But notice our left side polynomial is not written in descending order. We can fix that too. Just rearrange your terms. Now the left side is written in descending order. Okay, and so ladies and gentlemen, now to factor this trinomial completely, notice there's nothing we can factor out of all three terms. And so we have to try to factor it as a difficult type of trinomial. Unfortunately, it's one where the leading coefficient is not 1. To factor these types, I showed you the grouping method. And so to begin, we would take the product of -6 and +2. And I would go back to using our product sum table over here. So the product has to be -6 times 2, or -12. And the sum must be a +1, the middle coefficient. So let's start listing factors of -12 in hopes of arriving at a couple that sum up to 1. Here we go. -1 and 12 are factors of -12, or 1 and -12. -2 and +6, or +2 and -6 are factors of -12. -3 and +4, or +3 and -4 are factors of -12. Now the only factors in this list that sum up to +1, the middle coefficient, are going to be -3 and +4. Those are the only ones that work, because those are the only factors that sum up to +1. Now we rewrite our trinomial as an equivalent 4-term polynomial. So we have -6x squared. The middle term gets split up and rewritten as the sum of our decided upon factors over here. So 1x is rewritten as -3x plus 4x. And now, ladies and gentlemen, we're going to group our first and last two terms by placing parentheses around them. Notice no sign adjustment is necessary on the last term, since we have a plus sign that precedes the third term. Now we're going to try to factor out something out of both the first two terms. And the only thing we can factor out of -6x squared and -3x is a -3x. And I notice I could have factored a +3x out of the first two terms, but I decided to factor a -3x out. Remember, ladies and gentlemen, you can always factor 1 or -1 out of any polynomial. I decided to also take the negative sign out of the first two terms. When you factor -3x out of the first term, -6x squared, you'll leave behind 2x. When you factor -3x out of the last term, -3x, you'll leave behind +1. Plus, what can we factor out of 4x and 2? Well, the only thing we can factor out of both 4x and 2 would be 2 times. What would we leave behind in doing so? We would leave behind 2x plus 1. Notice now that we have a common binomial factor that's shared by both these terms. Being the case, we can factor the whole binomial factor of 2x plus 1 out of both these terms. There it is. Times, what do we leave behind in doing so? Well, we leave behind -3x plus the 2. Now what we do is we set both factors equal to 0. I'll do that over here. So we set 2x plus 1 equal to 0. And we set the other variable factor, 3x plus 2, equal to 0. All that remains now is solving these equations to wrap this problem up to get our two solutions to the second degree equation. Solving the first equation, we subtract 1 from both sides, divide both sides by 2, and one solution to the second degree equation is -1/2. That's one solution. The other solution will be found by solving this first degree equation for x. We minus 2 from both sides, divide both sides by -3, and we get our other solution as being x is equal to, now a negative over a negative is equivalent to a positive. So we just call this other solution +2/3. And we are done, ladies and gentlemen. The two solutions of this nasty second degree equation up here are -1/2 and +2/3. All right, let's try another one here. How about 2w squared is equal to 10w? We will try to solve the second degree equation for its two solutions. First of all, we need to make sure our equation is set equal to 0. To ensure that, we're going to have to move a positive 10W to the left side of our equation by subtracting it from both sides. So we subtract 10W from both sides of our equation. In doing so, our equation then would be set equal to 0. Now we try to completely factor the left side of this equation. Notice out of both terms on the left side of our equation, we can factor a 2 and a W out. Times, what would we leave behind? We will leave behind W minus 5. Now we set both variable factors equal to 0. We set 2W equal to 0, and we set W minus 5 equal to 0. And all that remains now is solving these two first-degree equations to get our two solutions to the second-degree equation up here. The first equation is easily solved by dividing both sides by 2. And 0 divided by 2 is 0, so 0 is one solution to our second-degree equation up here. And the other solution is found by adding 5 to both sides of our equation, in which case we get W is equal to 5. And we are done. So the two solutions of the second-degree equation are 0 and 5. So we're done with that problem. All right, we'll try this one. I'll try to solve a squared equals 36 for its two solutions. Notice we are going to get two solutions because it is a second-degree equation. First of all, we have to get this equation set equal to 0, and to do so, we're going to subtract 36 from both sides of our equation. Once we do that, now the left side can be factored upon inspection and thought. We realize that we have the difference between two squares here. 36 is the perfect square of 6. So that being the case, this binomial can be factored into the product of conjugate binomial factors, namely a plus 6 times a minus 6. Now we set both variable factors equal to 0. And we have two equations to solve. This first equation can be solved by subtracting 6 from both sides, in which case we get a is equal to negative 6. That's one solution to our equation up here. And the other equation can be solved by adding 6 to both sides, in which case we get a is equal to positive 6. And we're done. So these are the two solutions, ladies and gentlemen, to this equation up here. Kind of makes sense that these solutions would be correct, because if you take negative 6 and square it, you would get back 36. Or if you replaced a with positive 6 and square it, you would also get 36. That's why these are both the solutions to that equation. All right, just a couple more here. Some of these now are going to require that we do even more algebra on the equation before we can solve it. Here's an equation we want to solve for x, and you know, the way it presents itself, it does not look like it's a second-degree equation, but it really is in disguise. On what you don't want to do, and temptation would have a lot of people wanting to set x equal to 12 and 3x minus 5 equal to 12. And their thinking would be because it looks like the left side is completely factored. But stop and think. That would be an absurd statement to say that both x is 12 and 3x minus 5 is 12. Because if both these factors were 12, 12 times 12 would not give you back 12. No, the only way we set variable factors equal to something is if that something is 0. So we're going to have to get those equations set equal to 0. But you know what? Before we do that, I'll tell you what. Let's distribute this x inside the parentheses on the left side of our equation. X times 3x is 3x squared. Minus x times 5 is 5x. Now we will subtract 12 from both sides. And now we have our equation set equal to 0. And now we're going to try to completely factor this trinomial on the left side of our equation. To do so, unfortunately, we are up against a difficult type of trinomial to factor, one with a leading coefficient that's not 1. To factor this trinomial, ladies and gentlemen, we're going to have to use the grouping method. So we start by taking 3 and multiplying it by a negative 12. 3 times negative 12 gives us a product of negative 36. And now we're going to have to try to find two factors of negative 36 that sum up to our middle coefficient of negative 5. Let's start listing some factors of negative 36. Negative 1 and 36, 1 and negative 36, negative 2 and 18, 2 and negative 18, negative 3 and 12, 3 and negative 12, negative 4 and 9, 4 and negative 9. These are all the factors of negative 36. But there's only 2 in this list that do sum up to negative 5. And that would be the last factors down here that I listed, because 4 plus a negative 9 are the only ones that add up to a negative 5, our middle coefficient. So being the case, this trinomial now can be rewritten as an equivalent 4-term polynomial, where the middle term gets split up and rewritten as the sum of our decided upon factors over here. So negative 5x can be rewritten as plus 4x minus 9x. Or I could have these switched around. I could have minus 9x plus 4x. Now that we've successfully rewritten our trinomial as an equivalent 4-term polynomial, we now group this 4-termer to factor it. Notice we must change the sign of our last term since we have a minus sign that precedes our third term here. Out of the first two terms, the only thing we can factor out is just an x. And when we do so, we'll leave behind 3x plus 4. Bring the minus sign down. The last two terms we can factor out of 3, and we'll leave behind 3x plus 4 in doing so. Notice now, ladies and gentlemen, we have that common binomial factor between both terms, of which it can be then factored out of both these terms. There it is. Times, what do we leave behind? Well, we're going to leave behind x minus 3. X minus 3 is left behind when you factor 3x plus 4 out of these two terms here. Now we set both these factors equal to 0 and just solve both simple first degree equations. When you solve the first equation for x, you would get x is equal to negative 4/3. That's one solution to our second degree equation way back up here. When you solve the second equation for x by adding 3 to both sides, you'll get x is equal to positive 3 as being your second solution to this second degree equation. And we're done. We will try to solve this equation for its solutions. Again, it does not look like it's a second degree equation, but it really is, because what we have to do on the left side of this equation here before we even get this equation set equal to 0 is we have no choice but to FOIL these binomials out on the left side. So here we go. A times a is a squared. A times a negative 3 is minus 3a. Multiplying our inner terms together, 2 times a is plus a 2a. And multiplying our last terms together, 2 times a negative 3 is a minus 6. Combining the two middle-like terms here, we therefore have a squared minus a minus 6 is negative 2a. And now, ladies and gentlemen, we're in a position to get this equation set equal to 0. To do so, we add 2a to both sides of our equation. So we add 2a to the right side, and we're going to add 2a to the left side. When we do that, we'll have a squared. Negative 1a plus 2a is 1a. Bring the minus 6 down, and the right side of our equation is 0. Fortunately, we do have an easy type of trinomial now to try to completely factor on the left side of this equation. To do so is pretty simple. All we need are two factors of negative 6 that sum up to positive 1, the middle coefficient. And after some thought, ladies and gentlemen, the only factors that fit the bill are going to be 3 and negative 2. These are the only factors of -6 that do sum up to +1. Being the case, this trinomial will factor immediately into a plus 3 times a minus 2. A plus 3 times a minus 2. Set both factors equal to 0. And now we just have two simple equations to solve. This equation, when you subtract 3 from both sides, will give us one solution as being -3. And solving this simple equation by adding 2 to both sides, we get our last solution as being +2. And we're done. So these are the two solutions to what really is a second degree equation up here. All right, ladies and gentlemen, I got one more, as this is by far the longest video that I've ever made so far. One more. Now this one's going to be an interesting one here, because this is no longer a second degree equation. As this one turns out, it's a third degree equation. A third degree polynomial equation, because the highest degree term is a third degree term. To solve this third degree equation, first of all, notice the equation set equal to 0. That checks out. Next step is, can we factor anything out of all three terms on the left side? And the answer is yes. We can factor a 3 and also a y out of all three terms. So there is your greatest common factor of all three terms on the left side of this equation, 3y. When you factor 3y out of 9y squared, you'll leave behind 3y squared. Plus, when you factor 3y out of 6y squared, you'll leave behind 2y. Minus, when you factor 3y out of 24y, you'll leave behind just 8. Now we need to entertain the possibility, can this trinomial left behind inside the parentheses itself be further factored down? And to do so, ladies and gentlemen, what I'm going to do is take this polynomial, this trinomial, pick it up, take it off to the side of my paper and wrestle with it separately over here. And then once I get it factored, I will bring back its factored form and replace this with its factored form. Notice this is a difficult type of trinomial to factor, one that needs grouping. So we take 3 times a -8, and 3 times a -8 gives us a -24. Two factors of -24 that sum up to +2, our middle coefficient, after some thought, would be 6 and -4. 6 and -4 are the only factors of -24 that add up to +2. We now rewrite this trinomial as an equivalent 4-term polynomial, where the middle term 2y gets rewritten as 6y minus 4y. 6y minus 4y. We now group together our first and last two terms. Must change the sign of the last term because we have a minus sign that precedes our third term here. Out of the first two terms, we can factor a 3y out, leaving behind y plus 2. And the last two terms, we can factor a 4 out, leaving behind a y plus 2. Now we can factor out the y plus 2 since it's a common factor with both terms, and in doing so, we'll leave behind just 3y minus 4. That, ladies and gentlemen, is the factorization of this difficult trinomial. We come back to the main problem here and replace our trinomial now with its factored form. And this left side of this equation has been completely factored. We now set each of these variable factors equal to 0. And we solve each of these three first degree equations. The first one, when you divide both sides by 3, gives you y is equal to 0. That's one solution of this third degree equation. The other solution will come from solving the second equation for y by subtracting 2 from both sides. We get -2. And solving this last first degree equation for y, adding 4 to both sides and then dividing both sides by 3, we would get y is equal to 4/3. We're done, ladies and gentlemen. We've solved a third degree polynomial equation for its three solutions. And we're done. I hope you enjoyed Chapter 6. Please continue to work on your factoring skills, like I said, as that is a critical skill for your survival in higher level math. Factoring requires a little bit of work, ladies and gentlemen, to become good at, and I hope you are spending time amidst the craziness in our lives to sharpen your factoring skills. I wish you all the best. I hope you all stay healthy, And I'll talk with you next week. Remember, if you ever have any questions, please get with me via email as soon as possible.